in case you guys are gone. All right, and then I'll post it. All right, the figure in exercise 24 and 25 are trapezoids. Find the ratio of the areas between 1 and 3, 1 and 2, 1 and 4, and 2 and 4, and then 1 in the trapezoid. All right, so our A says we need to compare 1, and that's my and symbol, it's not plus, 3. Now, we only have 3 ways to compare areas. One is if they're similar, we find a scale factor and square it. If they have the same base, we compare the heights. If they have the same height, we compare the bases. Well, if I look at 1 and 3, look how far away they are. We don't know the heights, we don't know the bases, so we're not going to do heights and bases. In fact, because this is a trapezoid, we have parallel lines. And with parallel lines, we have similar triangles. So these two triangles are similar triangles. They are similar. When we go the route of similar, we have to come up with our length ratio first, and then we find our area ratio. So from 1 to 3, our length ratio is going to be 1 to 3 will be 5 over 10, which equals 1 over 5. If my length ratio is 1 over 5, what's my area ratio? 1 over 2. 1 over 2. Thank you. Pew, pew, pew. What is my area ratio then? If I can write ratio. Just shout it out. What is it? 1 over 4, because we would just do 1 over 2 squared equals 1 over 4. And if you look at the problem, it's actually asking for your area ratio. However, it's important that I know that length ratio. That length ratio is going to preserve for every single one of these lengths. So imagine this. I'm going to call every one of these sides as something. So let's say that this ratio, 1x, and this would be 2x. That would preserve that ratio. If 1x equals 5, that means my x equals 5, multiply 5 by 2, and I have 10. That's what a length ratio works. Basically, whatever this is, I multiply it by 2. Well, that applies for every one of these sides. So if I find out, say, this side is 1y, that means this side is going to be 2y. Let's say I come up with this side is z. This side would be 2z. I guess I can put 1s in front of them. That will preserve that 1 to 2, 1 to 2. If you look at my answer key, I just made them all 1x to 2x. Because it doesn't matter as long as you realize that each side might be a different length. They're not all 5 and 10. But they could be. It would preserve that ratio. I need to know this to do any more problems on this thing. So right now, do you have any questions on how I labeled these? You have to know how to do that, otherwise you can't do any more of this problem. Take any of those notes? Okay. Are we good here? Like I said, if you don't know this, you can't do anything else on this problem. What was that? Okay. I just want to make sure, because if you can do this, we can get the rest. Okay, then our next length, RB. RB is comparing what? 1 to 2. So 1 to 2 is not similar triangles. 1 to 2, on the other hand, what I need to look at is they have the same height. So if I drew a line for a height of 1, so if I look at the height of 1, let's do a dashed line. That height meets up with this base. This height also meets up with this base. So these triangles have the same height, but they have different bases. So same height, different bases. Our area ratio will be combining their bases. So our area ratio will be comparing our bases. Well, this base, although I don't know the value, we have like 1y here, or 1x, however you have it. This is a 1 to 2 ratio. So my area ratio is going to also be that 1 to 2. In other words, I have 1y over 2y. The y's cancel out, and that equals 1 over 2. So knowing this area ratio, we just need to know that this is a 1 to 2 from this scale factor. In fact, we could have just used the scale factor and go, oh, this is just 1 to 2. I can just put it as 1 to 2. I don't have to use variables. Well, our next one is a 1 to 4. That is our C. Once again, if you look at it, it follows the same situation. 1 and 4 are not similar triangles. Instead, 1 and 4, let me just erase this real quick. If I draw the height of triangle 1, we're going to see that height also applies to triangle 4. They have the same exact height. This right angle applies to this entire line. So 1 and 4 have the same heights, and their bases are 1 to 2. So our area ratio is 1 to 2. As a quick reminder, when we compare bases, you do not square it. So it's just 1 to 2. It's not 1 over 2 squared. The only time you square it is if you got the length ratio first. All right, to get from 2 to 4, you have to look at your ratios you already have. Well, 2 to 4, that would be our D, I guess. Well, if we look at 1 to 2, it's 1/2. 1 to 4 is 1/2. If I look at someone, they're half my height, and I look at someone else and they're half my height, what do we know about those two people? They are the same size. So if this is 1 to 2 is 1/2, 1 to 4 is 1/2, then 2 to 4 must be the same size. But that's going to mean that the ratio, if you had to do a ratio, would be 1 to 1, or just 1. Okay, and then we have to do E, and that is our 1 to our entire shape. So 1 to our entire shape would be this equation, 1 over 1 plus 2 plus 3 plus 4. And what I'll notice about is 1 to 3 is 1 over 4. 1 over 2. 1 over 2. Do you note how 1 is 1 in all these situations? So that means I'm going to replace my 1s with the actual number 1 because they're 1s in all that ratios. So it'll be 1 over 1 plus, we go to our 2 1. Well, 1 over 2, my 2 is actually a 2 here. So we'll go plus 2. For 3, we come up to this one. Well, that's a 4 because it's 1 to 4. So if my 1 is 1, then my 3 is 4. And finally, we come down to C. C says 1 to 4 is 1 over 2. So my 4 is 2. So that's going to equal 1 over 1 plus 2 is 3, plus 4 is 7, plus 2 is 9. It is 1 to 9. Questions on that one? The next one is almost identical except for the last step. So I'm going to take a picture of it. It is identical up to the last step. So on number, not 25, yeah, 25, it says compare 1 to 3 on this trapezoid. Once again, they're similar shapes. So I come up with a scale factor, which is 4 to 9, which means our area ratio is 16 over 81. That is our area ratio between these two, because our scale factor is 4 over 9. Which means every one of these preserves that 4x to 9x ratio. That's what a length ratio is. It preserves everything. So when I'm comparing 1 to, say, 2, which have the same heights, we're going to do 4x over 9x. if I compare 1 to 4, maybe I'll draw that picture of the height again. 1 to 4, they have the same height. So we just got to compare the two bases, which once again would be 4x over 9, or just that 4 over 9. So we'll see when I compare 1 to 2, it's 4 over 9. When I compare 1 to 4, it's 4 over 9. That will also lead us to D being 1 over 1, because they're compared to 1 being the same size. But we have to realize something. In A, my region 1 is 16. In B, my region 1 is 4. You can't come down here and put 16 and 4 in the same spot. Your region 1 must be consistent on all three of these. So to make it consistent, I'm like, okay, my 1 is 16 here. Right here it's 4. What I'm going to do is I'm going to take that 4 over 9 and I'm going to multiply the top and bottom by 4 to keep it still balanced, which will give me 16 over 36. Now my region 1s are both 16. I have to do the same thing here because I have a 4 here, so I have to multiply the top and bottom by 4, which will give me 16 over 36. Now all my region 1s are 16, so I can come down here and go, oh, region 1, 16. 16 will also go right below it. And then I just have to go in order. Region 2 is 36. Region 3 comes from my A, which is 81. And finally, region 4 is 36 from here. We get 16 over 169.